Hello students, I am Manish Singh, Assistant Professor in Computer Department in Assoit College. In this presentation, we are going to learn the fundamental concepts of computer network. The first topic is topology. Basically, there are five topologies in our computer network. First one is mesh, star, bus, ring, and tree. So first of all, we understand what is topology. Topology is a geographical representation of a computer network. Means how your computer network looks. This is called topology. First, we start with star topology. Star topology, you can see the figure. From the figure, you can understand why it is called star topology. Because in this figure, there is a one central device that is called hub, and all the devices are connected to the central devices. This is why it looks like a star. That's why it is called star topology. First of all, we understand how it works. Then we going to advantage, then disadvantage. In the star topology, suppose PC1 wants to communicate to PC3. It will first send the packet to the hub, and now hub will broadcast the packet to all the devices. First of all, we have to understand what is broadcast. Actually, basically, we are using three terminologies: unicast, multicast, and broadcast. In unicast, that is called point to point communication or one to one communication. Now, the second point is called multicast. When a one device sends a packet to a multiple devices, that is called multicast. And the third one is that is called broadcast. When a device sends a packet to all the devices, this is called broadcast. So the hub is broadcasting the packet to all the connected devices. No, I'm first of all we have to understand why it will just behave like this. Because hub is a non-intelligent device and it works on a physical layer of OSI model. Basically in OSI there are seven layers, and OSI is the physical layer is the last layer of OSI model from top to bottom. Okay, this is the nature of hub. It will broadcast the packet. So first of all, we go to the point to first number point. Each device has a dedicated point-to-point link only to a central controller, usually called a hub. Means PCs are connected to a via hub, not directly. Now the second point is no direct traffic and link between the devices. Means they cannot communicate directly. They have to communicate via hub. This is called uh, uh, how they work. Now come to the advantages. The first advantage is less expensive. You can see in the figure, you need less hardwares. You used only one hub. Suppose I want to connect one more PC. Simply I connect to a hub. That PC comes into the network. Okay. The next one is easy to install and reconfigure. As I have told, if you want to connect, just you connect into the hub, your PC comes under the network. Robust, you can rely on that network. The main disadvantage of this star topology is that is called single point failure. What do you mean by a single point failure? As you seen in the figure, all the devices are connected to a central device that is called hub. If hub going to be down, your all devices not going to communicate with each other. Means your complete networks fail. That's why it is called a single point failure. I think it will understand to all how your star topology work and what are the advantages and what are the disadvantages of star topology. Now we move to the next topology, that is called mesh topology. From the name mesh, or you can see in the figure how your mesh network looks like. In a previous slide, you have seen star topology. In this slide, you have seen that is called mesh topology. In star topology, all the devices connected via hub, but not in a mesh topology. They are connected directly using a dedicated link. Means suppose PC1 wants to connect to another PC, they use a dedicated link. So in this figure you can see There are 5 PCs, and each device is connected via dedicated link. That's why it is called a mesh topology. Every device has a dedicated point to point link to every another device. Okay, what do you mean by dedicated? Links carry traffic only between the two devices it's connect. Suppose this is a device 1 and this is device 2, and there is a link between the two devices. This link carries only the data between the two devices that cannot be shared by the another device. That is called, it's a dedicated link. A fully connected mesh network has n into n minus 1 two physical channels to a link n devices. First of all, we have to understand what is this formula. N into n minus 1 divided by 2. That will give you the number of links that can be used in this network. Suppose this is a network of 5 PC. N represent the number of devices. In this network, there are 5 PCs. So in this formula, 5 means 5 into 5 minus 1 means 5 4 ja 20 divided by 2 means we are using 10 links in this network. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is with the help of this formula you can get the number of links used in this network. Every device on the network must have n minus 1 input output port. Suppose if you want to find how many ports used in this network, so you can use this formula n into n minus 1. It will give the number of input output ports. What do you mean by ports? Where you connect your PCs, that is called port, and the link that is connecting two devices, that is called a link. What are the advantage? Advantage of mesh topology is less traffic, robust, secure, and easy to maintain. Less traffic, as we have already told, the link carries the data between the two devices. No another devices can use the link. Means there is no sharing possible of link. So there is less traffic. Robust, secure, because your data travel between the two devices. No information is sharing is possible via another devices because link is shared between the two devices. It's a dedicated link. Easy to maintain. The disadvantage, need more resources, just like for example cables and port, and that makes your network more expensive. Though, so you can tell, you can understand this cannot be considered for a big network. Big network means it cannot consider for 100, 200, and 300 PCs because that makes your network more mashy. So it can be used only for a small network. Suppose if I am going to make a network for my home, in that I am going to connect 2, 3, or 5 PCs. So I can use this mesh topology because I do not want to buy one another central device that is called hub, switch, or router. So that can be used for a small network. I think this can be understood to everyone how your mesh topology works and what are the advantages and disadvantages of the mesh topology. Now we are going to move on the bus topology. From the figure, you can understand what is bus topology and how it look likes. In this figure, you can see this is how many PCs we are going to connect it in this network. 4 PCs by using a backbone cable. In this network you have seen there is a one tap and drop line. All the PCs connected to a backbone cable using a tap or a drop line. First of all, we have to understand how your network works. First of all, I'm going to discuss one protocol that is called CSMACD. That is called Carrier Sense Multiple Access slash Collision Detection. Okay, suppose why it is called carrier sense multiple access collision detection. First of all, suppose this is your PC1 wants to communicate to PC4. First, it will sense the backbone cable. That's why it is called carrier sense. Why it is called multiple access? Because in that topology, multiple devices are connected to a single cable. That's why it is called multiple access. Suppose PC1 sends the cable, and it will find the cable is free. Then how you understand your cable is free? Suppose PC1 sends your backbone cable, and it will got the 0 voltage, means your cable is free. And suppose if your PC1 got the 5 voltage, means your cable is already in use. So when your PC1 gets 0 voltage, it understand your cable is free. So it delivers the packet to a backbone cable, and your packet travels from this backbone cable to a PC port. This is how works in a controlled manner. Suppose PC1 wants to data sends data PC4, and this device, suppose PC1 sends data to PC3 and PC4 sends the data to PC2. If both the devices sends the cable at the same time and both the devices get the same voltage 0, so they both understand cable is free and they send the data. But meanwhile, in the center of the backbone cable, packets are collide, means there is a collision between the packet, and it will destroy the packet. So after this collision, your network will broadcast a packet to each and every devices. There is a collision, so each and every devices connected to the backbone cable, they stop transmitting the packet. After some time, each and every devices, if they want to send the packet, they sense the cable, and if the cable is free, then they start the communication. This is how your bus topologies work, and this is how your carrier sense multiple access collision detection protocol works. Okay, a multi-point topology. All devices are linked through a backbone cable. Nodes are connected to the bus cable by a drop lines and a tape. This is called drop line, and the connected through this they are connected, that is called a tape. Drop line, a connection running between the device and the main cable, that is called a drop line. Tape, a connector that either splices into the main cable or punctures the sterling of a cable to create a contact with the metallic core. It's a one kind of connector, that is called a tape. Then what is the advantage? Ease of installation. You can easily install this bus topology. Then what are the disadvantage of bus topology? Difficult to reconnection and fault isolation, because all the devices are connected to a backbone cable. So it is very difficult to find the faults and to troubleshoot them. Broken or fault of the bus cable stop all the transmission. If the backbone cable breaks, all the network goes down. So this is the working of bus topology and the advantage and disadvantages of the bus topology. Now we have moved to the next topology, that is called ring topology. I think we already seen star, mash, bus. I think this should be understood by everyone. Now we move to the last topology, ring. Why I'm calling this a last topology? Because this is one another topology that is called tree. Tree is just another representation of star topology. Okay. Now we in a further slide we talk about the tree topology. Now first we talk about ring topology. From the figure you can understand how your ring topology looks like. It's a ring like structure, that's why it is called a ring topology. Each device is dedicated point-to-point connection only with the two devices on either side of it. Means this PC connected via point-to-point connection. A signal is passed along the ring in the direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. Okay. Why it is called ring topology? Suppose PC, this is suppose, understand it's a PC1 and this is PC2. If PC1 wants to send the data PC2, it will sends in a, your packet travels in a unidirectional, means it clockwise or either anti-clockwise. Suppose this PC wants to send data to this session, it will goes like this, not from this device to this device directly. That's why it is called unidirectional, and it will works in a anti-clockwise or a clockwise uh, movement. Okay, how basically there is a one device that can be used in a ring topology, that is called token. Suppose this station want to send the data to this station, it will first it will send the token. Suppose your token is free, it will send the packet to the token, and your token travels in the ring topology in a clockwise or anti-clockwise direction, and your data will deliver to the next station. This is how your ring topologies work. What are the advantages of ring topology? Relatively easy to install and reconfigure. Fault isolation is very simple. Disadvantage: unidirectional traffic. If PC one to send data to this PC, it will goes in this manner from this device to this device. It cannot goes from this device to this device. That's why it will take too much time. That's why it is called unidirectional. I think from the figure you can understand how your ring topology work using a token. I think now we come to the last topology, that is called a tree topology. In a tree topology, you can see the figure of star topology. You can move the hub to the top, and you can move the all devices in a down direction. It will look like a tree structure. So it's called a tree topology. So basically, it's a advanced version, or it's a different representation of star topology. I think I have covered all the topology. Thank you, everyone. So we are going to stop our today's session. Thank you, everyone.